And
Okay.
I forgot to record. I'm recording. Go ahead,
Okay.
sorry.
So we're all good?
Yeah. Noise is just my problem.
I'm able to hear you.
Yeah, go ahead.
Okay.
Yes,
Thank
okay.
you. So if it's not this elasticity, elasticity is scalability plus automation plus optimization. And the more important thing here is the automation, that it needs to auto scale and it can be up or down. So that's why it's not the same as the previous names, because it needs to be automated. There's one thing with auto scaling, it's that once you can be over provisioned or under provisioned. The issue with over provision is that you are paying for resources that you are not using, right? And under provision, you can have issues like service level agreement not being reached. So this is not something that you would like if you have a contract with a company. And also you don't want to have over provision, which would be the less issue, but you're paying much, well, you're paying for something that you're not using. So that's not something wanted. And there, the paper says that there are other papers which has some equations to calculate how you can be over provision, under provision, or just in need, which is a new state added just for those calculations, and that you can do those calculations on your machines or your resources that are provisioned. This one thing that this paper did was to put elasticity on 7 different solutions, or it classified elasticity in 7 different ways, and it's the first paper to do that. The first one would be configuration. It can be rigid or configurable. The issue with rigid is that rarely meets the demand and is always over provisioned or under provisioned. The configurable, it can be based in 4 different, like immediate reservation, you reserve the resources when you need it. In advance, you say, hey, I will need more CPU the next minutes or so. So it does the reservation before you actually need. The best effort reservation, which is just best effort, it will try to get your resource. And an auction-based reservation, which I found particularly odd, like the better bid will get the resource. So it's kind of, I don't know, yeah, capitalist way to do it. Another way is scope. Depending on the scope, it can be in infrastructure and applications on platforms. The infrastructure will be containers and VMs, which we will talk later. And applications, it's a single tier or multi-tier. The single tier are mostly in the business tier, and something regarding the multi-tiers, it says that some elasticity controllers support sticky sessions. What's a sticky session? It means that you tell you have a session and it's connected to a server, and you say, hey, I want this session to be sticky, so it will remain in the same server to make things more efficient. So it's something nice, instead of just bouncing between servers. The Elastic applications there, they adjust their own resources, but there's this issue where like elasticity means that it should be automated, right? So if an Elastic application needs to do it manually, it breaks like this idea of automation, and it's giving the developer the responsibility of scaling the application, which breaks this idea, right? Also, another classification is the purpose, which it can be the client will want full availability of their application, or they want to restrain the energy, increase capacity, restrain cost, and improve performance, right, of their applications. So there's not one Elastic server which can fulfill all these purposes at the same time. It's like there's not one ring to rule them all. So another classification is mode and policy, which it needs to be automatic to be Elastic, and this is divided in reactive and predictive. The reactive is with dynamic thresholds or threshold-based policies. We talked these threshold-based policies in the previous presentation. Like one threshold-based policy could be like if you are at 80% of CPU over some period of time, then you increase the CPU resources, you give more CPUs to that application. And also if you are just doing 20% of CPU or less, then you reduce the number of CPUs. This would be a reactive approach. And also there's a predictive approach, which uses all these time series analysis, machine learning, patterns, regressions, and so on. And also there's other way to do these predictive policies through model solving approaches like open loop, which is cheap and simple, feedback controllers, feedback and feedback forward, and also both reactive and predictive can also use control theory, queuing theory, and reinforcement learning. The next classification method is method and action. This is like a vertical scaling or elasticity doing vertical, which is CPU, memory, or both, or even more resources. It doesn't always need to be CPU or memory. And horizontal. The horizontal means more machines, like we have seen in previous classes. Also, vertical is known as fine grain. And you can do both horizontal and vertical. And to do this like hybrid or horizontal, you need to do it through a resource allocation strategy. That's RAS. This helps you to migrate or replicate a VM. Another classification is the architecture. It can be centralized or decentralized. What does it mean to be a central Elastic? It means that you have only one elasticity controller. And decentralized, well, you do it through multiple Elastic controller. And this is done through multi-agent system providers. And the provider, it can be single or multiple, like cloud providers. Now, how does this elasticity, how you can evaluate this elasticity performance? It says there's no standard. You can use some simulators. These are the ones mentioned in the paper. And it also mentions that in public cloud, since the resources are shared, it's more complicated to evaluate because you can be sharing CPUs and memory, and that's why you're not getting like the full throttle of a CPU. You can try to evaluate the elasticity through applications benchmarks, synthetic workloads generators, real workloads. The issue is that the workloads are too diverse and it doesn't exist like a single elasticity algorithm to evaluate them. There's something nice, a term called breadth duration, which is the period of time left to the system to reach a stable after a scaling decision. So this breadth duration typically should be small, because once you allocate the resources, you want to scale quickly them, right? The containerization. What's a containerization? Well, this is another way to virtualize the environments. Like you can have the virtual machines and you can have containers. Containers are much resource efficient. It reduces the needs for a hypervisor, like you see on this part of the image. Like you have Docker and you don't need hypervisor on top of the operating system or on top of the hardware. The container isolates and controls processes and resources. And Unix or in Linux, it uses like namespaces and C groups, which doesn't cause any penalty in performance. The containers are portable and consistent. One thing like they branded long ago is like shipping your laptop where the programs actually works. So you don't need to worry that in another computer it won't work. The one issue against containers is that they are not as secure as virtual machines, since processes aren't completely isolated. The technologies talked in the paper are Docker, LXD, Rocket, LXD, which use also Linux containers from LXC, and FreeBSD jail. This container technology is kind of old. It has already existed over a decade, but it hasn't been used so much as in recent years. One thing about containers, you need to manage containers. So in order to do that, there's another program which does the container orchestration. Here are some examples of them. The first one is Docker Swarm, which supports like Docker and Rocket containers, which the papers were the most popular ones. Kubernetes, which also supports Rocket and Docker containers. Koros Fleet, which is designed to be fault tolerant, supports Rocket and also Dockers, and it's a low-level cluster management tool. So you can use CoreOS, and on top of that, use Kubernetes or like Docker Swarm. Apache Mesos, which is being used for large-scale clustered environments. And last but not least, the OpenStack Magnum. It facilitate the use of containers in OpenStack. The unresolved issues so far is interoperability. There's the lack of a standardized APIs between cloud providers. It's difficult to use different providers. Now, there are several organizations like ISO and the National Institute of Standards and Technology, NIST, and the IEEE with standards to improve this interoperability, but we need like that the enterprises abide these standards to make interoperability easier. The granularity, the issue is that most elasticity are based on horizontal elasticity. There's not much like fine grade issue, like there isn't a reduction in CPU and memory. Normally, if you want to reduce one of them, I mean, if you want to reduce them, you can only reduce or CPU or memory, but not both. So it's an issue there. Also, most cloud providers use hour as a minimal billing time. Container billing has prices ambiguity. There's no standardization in prices for containers. And startup time or spin-up times affects the efficiency and the billing. The resource availability is another open issue. There isn't a provider which can give you unlimited resources because that doesn't exist, even though that's how they sell it. It's limited to the cloud infrastructure. The issues in there, it's like latency bottlenecks and hiccups in performance. The hybrid solutions, there isn't a reactive and proactive approach, so there should be one of them to improve this elasticity. With this, we will avoid over provisioning and or under provisioning, sorry. And we need to see which is the best trade-off between cloud provider and user interest regarding quality of service and the use of the resources. The evaluation, there's no, like I said previously, there's no standard for evaluating elastic solutions due to the heterogeneity of elastic systems and workload behaviors. The research challenges, monitoring containers. They said that there aren't tools to monitor containers, but if you do a quick search in the internet, you'll see that there are lots of tools to monitor this. Containers and virtual manager plus, I mean, virtual machines plus container elasticity. Does the virtual machine solutions can be applied in containers? Does the proactive approaches improve the resource usage? And this is for the containers, the questions for the containers, and the questions for the VMs plus container is having VMs with containers can lead to efficient resource utilization, like here in the first two virtual machines, like having a container inside a virtual machine, does that lead to better resource utilizations? Because containers are, in this way, containers are limited by virtual machine resources, but the good thing is that containers, I mean, virtual machines can be expanded, can be moved. So the challenge is to coordinate elasticity between the virtual machine and the containers, so there are no like hiccups or issues seen by the application. And that's all. Q&A.
Yeah, I have a quick question. The paper mentions something about containers not being particularly secure.
Yeah.
But this paper is like from 2018. And one of the features from the Linux kernel that powers containers are namespaces. And
Yeah.
as far as I can tell, they seem to be like safe and do provide like good level of isolation. So do you know exactly what they mean by these security implications, or does anyone know? Because I honestly did not go a lot deeper into this. But
Namespaces are part of the orchestration. It's not the container by itself.
no,
but it's containing,
namespaces
yeah,
is part of the
namespaces, yeah.
container technology. Like Docker depends on C groups and namespaces to create containers.
Yeah.
Not really for create containers.
Yes.
yeah.
Yes.
Yeah.
Containers depend on C groups for controlling the amount of resources that these processes get, and namespaces for isolation.
Yeah. In Linux,
But
yeah.
namespaces is networking topic, right? And the other is computing topic.
No, namespaces at the PID level. Like the processes within one namespace cannot see the process from a different namespace. So it's a
Yeah, but either
it's
way,
a
it's
process
networking,
level
right?
isolation. Huh?
Yeah, it's a process level, but it's still on the topic of networking.
Not really. It's on the level of I'm running on a machine. I cannot like do a PS and see other processes. Like as far as I know, I am my own world.
Yeah, but they share their resources, right? Like the RAM, and they can do like this, like how you say, like Spectre, and those kind of like
Spectre and Meltdown.
Yeah, and those kind of attacks, like also I don't know the name of that. Like they just surround memory.
Okay, so
that one.
it's okay.
So like even if you have this isolation of the processes, like at the OS level, you don't have like this isolation in the machine, right? In the physical world.
But the paper specifically contrasts them with virtual machines, and VMs are also running on the same hardware, right? So they should, I guess, theoretically still be subject to the same kind of problems.
But
you receive reserve a specific piece of the memory, right? And it's not accessible to, well, the hypervisor has access to it. But if you have two VMs in the same environment, they are not able to consume the RAM from the other one, right? Isn't it? As far as I know, I mean, that concern that we were discussing is just for Docker itself.
Yeah, you reserve the memory.
Yeah, the other one, once that it's reserved, the next VM cannot access. You need to reserve the next chunk, right? It is not.
Yeah, but still, they are processes that are co-located in the same machine, right? Like they are sharing the hardware. Like they're at the OS level, at the software level, they are not sharing the RAM. But at the hardware level, they are, right? Just as containers.
Yeah.
So I mean,
yeah, but the security concerns are different, right? It looks like in Docker has more security concerns than the old virtual machine. But something else that I would like to add is when this paper was released, Docker was like 3 years old since release. So now it has 8 years old, 9 years old. It has almost 3 times the maturity that it used to have at the moment. So it's possible that some of those restrictions are fixed now. Not sure if someone know about that or that could share with us. But
yeah, that's also kind of what I asked. Like this paper is from 2018. So I'm wondering, like in these 4 years, like how much these security concerns have been addressed. I honestly don't know.
Probably it could be a design flaw, right? And those are pretty hard to solve.
I don't know, because I mean, Spectre and Meltdown, they're a problem with Intel architectures, right? Like with caching and with like branch prediction and stuff like that. They are completely like, regardless of whether you're running a VM or a container, It is a problem with the underlying architecture, right? So I'm guessing some of these problems. The paper says that containers are more insecure than VMs, but I don't know if that statement, like, I don't know exactly what they mean. Like, they don't actually go deep. They just said to provide the same level of isolation between containers as VM do, right? Like, and it's talking specifically about isolation here. And that's why I brought the namespaces thing, because I mean, it sounds like they bring good isolation, but honestly don't know at the kernel level what's going on.
Go on, Rodrigo, sorry.
Yeah, sorry, I'm not an expert, just did a quick Google search and just found out that here that one, the containers are attached to the same virtual network, so they can be attacked through the same virtual network. And the other one is that container may fulfill the disk space of the host quicker, I guess. I mean, in the virtual machines, I guess you can put harder restrictions on that one. However, from my usage of Docker, I have already for Framework for Compose, like limit the space of the host. So I believe this one is no longer valid. And the last one that they say is that a compromised container may cause a CPU starvation of the host. So I guess there you have it.
Yeah, but I don't know, because like that's precisely what you have C groups for, right? Like C groups.
Yeah, that's the main idea.
Memory and CPU usage. So it could be. I mean, theoretically, containers could lead to starvation, but I'm guessing that technologies like Docker make a pretty good use of C groups to avoid that kind of thing. Right?
Yeah, but
and it just kills your process.
You're talking just when the container is running. But there are a lot of things before a container is running. Like, for example, when you are creating the image of the container, sometimes you're using a base image from another person or from another organization. So you can check your code, you can check your security branch issues there, but you cannot check whatever they are injecting in your image. So you don't know if in that part you are getting a leak or something like that. That's
I mean, but I guess the same could be said of using VirtualBox, right? Like, you don't know how many bugs they have, or VMware, or whatever virtualization for that matter.
Yeah.
I mean, I guess we're making the assumption that the systems, the underlying infra that we use is like bug free, and based on that assumption, like you start this process of like how secure it is, right? Like, assuming it is perfect, how secure it is.
Also, you also can have issues related to best practices. Containers are supposed that they cannot storage data, but sometimes developers or for some bad guides, persons are storing information in the containers, and also that can lead to a security issue. So there are a lot of things besides just the container running by itself.
But in the case of security,
I just want to mention that I agree with Ricardo that even there are different software divisions, they are sharing the same hardware. I was recently studying about the memory banks and all of that stuff, and they are basically accessible for at one time. This does mean that there's a security issue, a real concern about the hardware, because all of them are accessing the same hardware. And you mentioned Spectre and also the other one,
Meltdown.
Meltdown, yeah. Those were the hardware architecture issues.
Yeah, like if you're running on an Intel chip, like you can get bitten by that.
And do that, the attackers could have access to all of what was inside the machine. For example, every virtual machine that there was in the server. So it's a valid concern to me. That's.
I have one question here. So, do you know if in the case of let's say in AWS, you have this service, the Docker server is shared across several customers? Or you have like your own VM, and then you can raise as many containers as you want, but you are the owner of those. Because that also I mean, it could impact in how shared container, if having access to other containers could impact you or not, right?
Yeah, I mean, it really does depend a lot. I mean, if you go like with EC2, you do have like, I mean, at the end it's a virtual machine, and on top of that virtual machine, you end up like you can there preserve warm, or you can go like a step like over the abstraction and go with Fargate or ECS, which is Elastic Container Service. And in that case, you don't have really control on the instances. And so you delegate. I mean, you can have both cases, right? Where you can go and install the Docker server yourself, or just leave Amazon to do that, and you just pass in the images, and that's it. I mean, you can decide on that one.
Yeah, but in that case, the service provider is in charge of all those security concerns, right? Not sure if they are covering them, but you are delegating that.
Yeah, I mean, if you go with AKS or ECS or Fargate, I mean, you do, as Ricardo was saying, you assume that one's secure, and you just go one and just worry about your image, and that's it.
Yeah, once you sell your soul to Amazon, you just close your eyes and sign, and it's like, hopefully everything will be fine, right?
Yeah.
But there are other security concerns there, right? Because, for example, you can manage what are the open ports and things like that. So not all the security, what are the roles or permissions that things or different services can have and things like that, right? It's not manage everything. Depending, right now, I think that by default, actually, you have 0 permissions and you have to add them instead of, because before it was, you have all the permissions and you have to remove them. But all the security is not on them, right? It's like a big part, but not all.
Yeah. I mean, you have to configure your VPC and your incoming rules and all those things that I thank God I have never had to do myself. But yeah, I mean, I guess the question is, if I deploy my application using containers, and if someone else deploys the exact same application using VMs, like the exact same code, whatever, is mine in containers inherently more insecure? Apparently the paper thinks so, but that was in 2018. So I don't know if someone knows.
I have something from O'Reilly. This one sounds kind of a little more trustworthy. It says that here that unlike in a virtual machine, the kernel with containers is shared among all containers and the host that we know, right? And so should a container cause a kernel panic, it will take down the whole host for them, since they are sharing all the same kernel. So yeah, well, there you have it. There's a case in which the virtual machine is a little better protected. I mean, we should really take a look. I mean, we need a security expert here.
So actually, there's a main difference between containers and virtual machines, right? That the virtual machines execute an operating system under the hood, but the other ones, the orchestration from containers is done only because of the libraries of the operating system. But as you mentioned, the kernel is shared, right? The main difference between the virtual machines is that they have their own kernel, their own operating system. And actually in the presentation, it looks like really clear there that you have to have an OS to execute, for example, how you say, Docker Compose, or how you say, Kubernetes, or something like that, an orchestration mechanism. And that's why actually it loads actually faster. When you are executing a virtual machine, you have to load an entire operating system. And when you are launching containers that are like, for example, Lambdas, you are only allocating extra resources that are actually the libraries. You know, even when you have like an image that it's based on Linux or whatever, but actually it's only libraries.
Yeah, and I mean they do provide this like complete replication of your setup, right? Like if my Docker file, if I can get it to run in my computer, it will be, I don't know how much guaranteed, but pretty much guaranteed to run everywhere, right? So, and fast. That's part of what they're selling, right? Like you deploy like consistent deployments.
Yeah.
One more thing that I just read is that my guess, there are already in the platform of the server, there are already hardware modules, physical modules that helps to the security of the system. They generate cryptographic keys for the access of this to this platform. So more than the software security, there are also hardware security modules now.
Wow, you know about it.
Yeah, I have another question. It's more related to the elasticity. What do you think we need to, well, the provider need to do for changing from the, well, right now it says that horizontal is a most used elasticity instead of vertical. For me, it should be better to use vertical than horizontal. So what do you think the provider need to address for doing this?
The thing is that, sorry, go on.
Yeah, like I don't know if I'm sure, but at least when I start learning about scalability, I know that all the automated one is horizontal because on vertical you have to provision hardware physically and you have to go to the racks and put the extra memory there.
Yeah, and also I believe if you go with vertical scalability, it is also more prone to, I mean, if you have an error on a vertical, if you start escalating vertically and you have something that drops the whole server down, you're done, right? I mean, and in the other end, if you start going horizontally, you still have like a more reliable in that sense because you only lose one of the many servers that you were using, and it's always easier. I mean, it's the go-to now, right?
Yeah, but it's more expensive.
Like people go on and use their machines
using horizontal than vertical, because in vertical you're using whatever you need specifically, and in horizontal they are going to you need to pay for everything.
I guess.
Sorry. Actually, the data centers of Google, Amazon, and all that stuff are using hybrid because it's more expensive to have set up, I don't know, with an Intel platform because it's not only the CPU. Maybe it depends on your needs because it maybe if you have, I don't know, a 128 core CPU and you have a 2-socket system, it will be expensive not to use both systems. Not all RAM, not all accelerators, not all. There are so many things that you can use. So actually, all the data centers use hybrid because of the cost, and it's more cheap to pay someone to put a memory if you need on a platform than having thousands of platforms with full of hardware and features. So yes. I know this because I work building data centers and building and testing silicon for this kind of companies in data centers. So yeah.
Okay, nice.
Okay, so one quick question now that you mentioned about the multiple clouds and the hybrid environments. So for example, we saw that one of the challenges was to perform the benchmark between different providers, but at the end we saw that Jose Antonio found some new monitors. So I don't know if someone knows of any monitor that allows to test that for the benchmarks and decide based on the cost or benefit.
Yeah, but in this case, sharing providers, it means like, for example, if you are with Microsoft and AWS, right? Not sure if I missed something, but the monitors apply for multiple providers, or it is in general? Because if it is in general, we have a lot of tools for that. You could use, for example, Portainer. I know that one is a UI that allows you to track all the behavior, well, whatever is going on your Docker installation. But what I want to say here is that not sure if the problem is specific to the providers or just monitor in general. Not sure if I missed something on there.
Yeah, so just to run the benchmark and decide which provider you should select, like to go with, based maybe on the billing, or to see if maybe with less resources is better for you than the other one.
Jose Antonio, you have something to add on
Yeah,
that one?
I think you can do that, monitoring like the different cloud providers. But the main issue here regarding elasticity was that if you have your benchmark, like you can use benchmarks, right? what you will think your workload is, and run it in the different cloud providers and monitor those and get your best, right? But the issue is like what the paper said in elasticity is that you don't have like one benchmark to say, hey, this is the best benchmark and this is the best like way to do elasticity, because it depends on different factors, like you said, the cost, or maybe you want a machine that runs slower because you don't need that much power CPU, and so on, right? Like you just need like a good quality of service for your application and low cost, basically. That's why depending on your application and what you need from the cloud provider, it's like this elasticity. Maybe you don't care like so much about the cost, but you need to be really, really fast. Like if you miss someone, like I don't know, if your servers go down or anything like that for a couple of seconds, you lose a lot of money. Then you don't care like how much it will cost you, right? You will need a different benchmark and a different elasticity, a different way to measure this. Do I make myself clear, or more or less?
Okay, yeah. So it will be more based on the experience from the user on the general service.
Yeah.
I have a question on that one. What is the goal of the benchmark? Is it really to decide which is the provider that you are want to use, or it's more to validate the policies that you have to decide when to do the upscale or downscale? You know, once that on a living system, you already configured decided which is your provider, right? So based on what I saw on the paper and the impression that I got, it's more like validating your policies and benchmark that with whatever you decided that is your proactive approach, it's really working or not. Not sure if I making myself clear or someone wants to. I don't know. Okay.
I think it was more related to how elasticity works in every provider, right? Like that sometimes it takes some time to adjust the load or well, the resources depending on the load and the work, the load and well, the request or whatever. So I think the benchmarks are more to test the elasticity, the elasticity algorithms that the providers are using. So for example, if you have I don't know, one virtual machine, and then suddenly you have a spike of load, then the provider should increase the resources, and then just for the right amount of time, right? You don't want to spend like 100 hours with all the resources, but probably that spike just lasts just 1 hour, right? Does it make sense? I think the benchmarks are more related to that. Not by selecting which cloud provider you want to use. Well, but yeah, now thinking about it, it will be also like will be important to consider that. So yeah, maybe it
could be a factor to take. The cost.
There in the chat, I just left, like I was just going through this paper on performance comparison study of clusters on public clouds. So, and as you were saying, basically, you need to decide what type of things you will be testing, how the benchmark will look like, and what platform you. I mean, in this case, they are only going with Spark, and they use something that is HopsWorks. So yeah, I mean, there you have it there.
Okay.
Uh,
Go ahead, Oscar.
I just wanted to add some comment at the end. One of the challenges that the author says is the ability to have like a mix and match provided option, have standardized APIs and that kind of stuff. But in reality, I think that the strategy for most of the providers is like beyond the Apple ecosystem. You know, once that you sign for your main database here, then you will start to see how your current business logic can fit into that platform, right? A scale just in that place. There is restrictions, for example, when you want to move to another place, for example, it's more expensive to place data in a database than retrieve it to ship it to some other site. So there are some artificial restrictions, policies to make you stay in that ecosystem. So I don't think that is
interoperability isn't a bug, it's a feature. I mean, imposed by the companies. They don't want to have it, right?
Yeah, there are business.
That's vendor locking.
Yeah, and everyone that is providing those services are companies, right? They need to think on the stocks. So I think that it's a challenge that it's really difficult to achieve, to fix.
It's true, but it doesn't necessarily need to be like this forever, or it would be like this forever. I mean, I think if we think about it historically, it's in a case like that different companies, they try to basically trap you in their own platform, an ecosystem, but eventually they have to, you know, let it open at some point, you know. It's not, I'm not saying it will happen, but I mean, I kind of understand why the authors talked about it, you know. But
yeah, actually today some companies have some coaliciones. I don't know what is the word in English. For example, you have access the Microsoft site from an Oracle cloud, right? But that is something that they agreed, and it's you only can work on those two platforms, right? Because there is some agreement between the two. But like in a general solution, I'm not sure if that is totally possible.
Yeah, I mean there are like very strong cases. I mean, for in the startups that I have been, the AWS goes on like with the combinator and tells them, hey, just use AWS and we'll give you like, I don't know, thousands and tens of thousands of credits. And yeah, I mean, we most of the times we get locked in. I mean, it's, and sometimes, and when we want to do something from GCP, like for example, tell you to use that one, it was like, okay, but why if we have AWS already paying for us for all of this? So yeah, I mean, there are some dirty sketches right there.
But regarding that case, the use of multiple clouds is not restricted, yeah? Amazon Web Services trying to motivate to use just themselves with this kind of prices or promotions, but as far as I know, every company can use as much as cloud services can be in the world.
As long as you have money, that's it.
Oh yeah.
Also, you have the flexibility, but they don't encourage you to do that, right?
Yeah, I mean,
the option is there, but
yeah, I mean, they were always like, whenever we were proposals, it's like, oh, okay, go on, tell me why GCP, and then I'll tell you how much it will cost. So yeah, I mean, those are many cases. I mean, in many of the startups, they go on and they start and lock them in right away.
I have a concern in automatic and in predictive thresholds. And you need to create a database and historical of the time series analysis to to get the thresholds in a very how do you say efficient way, but how many times do you need to acquire that data to pass the algorithm for machine learning, for example, to take the thresholds for the optimizations? How many days, hours, months will take to take the amount of data that machine learning needs? I don't know.
Yeah. I guess that's a very difficult one, right? I mean, it does depend like a lot on the type of the application and the traffic that you're expecting, but mainly, I guess in the ideal case, you just go on with like a first forecast and then let
to some.
I mean, you leave it like that, while on the other end, you still tweaking the system on the other end. And every so often, when you have enough information, you go on and again release into production these new parameters and then test again for a while. But in the meantime, you are also retroactively like feedbacking into a new system that could potentially eventually like replace the new escalation parameters or elasticity parameters. I mean, that's the way that I have been seeing it for a while.
Yeah.
But I mean, to be honest, like the first time doesn't really work very well. I mean, it would be very nice to have like a better initial estimation. I mean, we have never managed to get it right the first time.
Okay, great discussion. Just a note about the paper. I mean, I'm trying to pick the papers that are coming from right journals with right authors. Okay, so at least reputable journals, but still, it doesn't mean they are basically absolutely correct. I mean, especially when we are talking about in the realm of academia, so they are coming from more academicians than practitioners. Okay, so still you can trust your own judgment based on your experience than maybe an academic paper. Just to clarify, and yeah, that's it about this one. Again, thank you, Jose, for presentation, Oscar for leading the discussion, Javier, hopefully for note taking. We'll check that out later. So for the next week, yeah, please check the schedule. I've seen still there are some changes. People are editing, moving names around. So try to basically finalize it. I mean, if you just don't remove or delete any other people name, please. Okay. I mean, you can change your name, you can remove your name, put it in another slide, another empty slot, but don't remove any other people name. So the papers are available in the drive, and the presentation that we just saw, they are both publicly available. That's how it should be. So you can access both presentation that they just present. And that's it.
Madi, for the two sides, when is the deadline?
Which one?
For the size for this class.
The summary.
Yeah, the two ones.
I said that I would ask you to submit all the summaries by September 15. Okay.
So on all the classes?
Yeah, I mean, in September 15, I put one assignment. I said, okay, submit all the basically paper that you reviewed so far. You wrote, you write summary. So it's not per class. It would be 3 times per semester.
And can you submit all the papers that we have to read so we can start reading it beforehand and start making all the summaries?
You wanna read them beforehand and write the summaries?
Yes.
Okay, sure. I can.
Because if you can submit all of them, I will
The
start
idea
doing it.
actually was I wanted to see how this things goes, and so I just adjust the papers as we go through. Okay, but I can put at least maybe like each 2-3 weeks ahead of time. Okay, so you can know what's coming in 2-3 weeks.
Okay, so you are going to upload the ones for September 1st?
Which one?
September 1st, 2 weeks before tonight.
Yeah, September 1st. Yeah, I will upload. Tomorrow I will put the names.
Okay.
I will put the papers and I will put the titles.
Okay, thank you.
Okay.
How about the deep dive presentations for September 15th? Who will be presenting?
So I would say the first 4 groups.
Okay.
So yeah, we have 1 people missing here, but Lambda, OpenStack, Spark, Kubernetes, complexities of note taking. That sounds good too. So yeah, pick whatever you want, but it's a deep dive because it's a 3 people work, so you can divide the job, prepare 1 presentation, then do that presentation. So yeah, I would say the first four, we go with the first 4 in September 15 and with the other 3, but I don't know when is the next one.
Okay, thank you.
Okay. Okay, then guys, have a nice evening, night. See you guys next week.
Thank you.
Take care.
Bye.
Thank you.
Take
Bye.
care. I will upload the recording later.
Bye.
Bye.
Yeah.